So now that we've gotten an overview of concurrent versus non-concurrent collectors, let's start doing a little deeper dive. And we're actually going to show how to implement non-concurrent and concurrent collectors. So this would be useful to know if you ever are in a situation where you have to make your own collector. So kind of a recap, we talked about this a couple times, but we didn't really do a deep dive until now. A collector is an interface that is a generic interface, and it takes three generic types whose names are somewhat obscurely called T, A, and R, but once you know what they stand for, it's easy to understand what they mean. So T is the type of object that's available in the stream. So if you have a stream of integers, or a stream of strings, or a stream of search results, or a stream of employee records, or whatever your stream is a stream of, then that's what T is. What is A? A is the type of the mutable accumulator object that's used as the collector, as the mutable result container. And this could be something like a list of something, a list of T, a future to T, a list of futures to T, a concurrent hash set of T, or whatever. You just have a bunch of different things that could be there. And of course, the list could be implemented as an array list, as a linked list, blah, blah, blah. And then R stands for result. And that's the type of the final result that's going to come out of collecting everything up into one result, into the final result, the finished result. And that again could be a list of something, or a future to a list of something, or a concurrent hash set of something, et cetera, et cetera. There are 5 methods defined in the collector interface, and we're going to talk about each one of them briefly and then show concurrent and non-concurrent implementations. The first method we're going to talk about is the characteristics method, and this is essentially a factory method that gives back metadata that describes what kind of stream, what kind of properties the collector needs to have. So, for example, does the collector need to preserve in counter order or not? So if you say unordered, then it won't really care, which is good. That makes it a little bit more optimized in some cases. A concurrent collector should be unordered, but a non-concurrent collector could be ordered, or you wouldn't set the unordered characteristic, because usually with non-concurrent collectors, in counter order just kind of comes along for the ride. There's also another characteristic called identity finish, and this is used by a method we'll talk about momentarily called the finisher. And if identity finish is set, then the finisher is a no-op. If identity finish is not set, then the finisher is expected to do something in order to take the accumulator and put it into whatever form is required when things are done. And that may not make any sense at the moment, but we'll talk about it when we get to the finisher. And then finally, the key thing we're talking about here is the concurrent flag, or concurrent characteristic. And concurrent simply means the accumulator is called concurrently on the result container, and therefore you need to have synchronization. A concurrent collector, of course, should be concurrent, duh, but a non-concurrent collector should not be concurrent. Because if you make a non-concurrent collector and you mark it as concurrent, chaos and insanity will break out, because it'll be called in multiple threads of control, and bad things will happen. Needless to say, if you have a concurrent collector, its mutable result container, which is what you provided for A, that was the accumulator type, must be a synchronized collection, or a synchronized container. Also, if you set concurrent, then the combiner method is a no-op, because you're not combining anything. If you don't set concurrent, if you're using a non-concurrent collector, then combiner is necessary. Now, this is a little bit confusing. So if you have a non-concurrent collector, it works with both sequential or parallel streams. It's just doing combining for the parallel streams. If you use a concurrent collector, then combining is never going to be called. And so you have to tell the framework what you need, and then it will make sure to enable the right behavior. Speaking of which, I saw a new movie this weekend. I saw the Shang-Chi movie, which was very cool. And as part of that, I watched the trailer, and the trailer for the new Matrix movie is out. If you haven't seen that, you should go watch it, because it's also on YouTube. And so the red pill, blue pill thing shows up all over the place in the trailer. It's pretty cool. Here's one way you can create characteristics. This is if you want the full Monty characteristics. If you want concurrent, unordered, and identity finish, you can say enum set of, and then set these things. And then you can actually return this as an unmodifiable set. That just means that there's no operations to change it once you've set it. So just a little bit of trivia. There's other ways, of course, to create collections, or sets rather, but this is one that will work for everything. The next method we're going to talk about is the supplier. And this is a factory method that returns a supplier, which comes back as a supplier, literally, a supplier, which is a data type from modern Java, that acts as a factory to generate an empty result container. And let's take a look at a very common example. This is probably the most common result that's returned from supplier, which is a constructor reference to array list. So array list : new is a constructor reference that will, when called, when the get method of the supplier that's returned, let me rephrase, when the get method of the capital S supplier object that's returned from the lowercase s supplier factory method, when the get method is called on the result of this, that will then call the constructor for array list if you give it the array list constructor reference. And that is a very common way to do non-concurrent collectors. In contrast, if you're doing a concurrent collector, then you need to give it a constructor reference for a concurrent collection. So ConcurrentHashSet is my little concurrent collector that will put things into a hash set that's made to be thread safe by wrapping concurrent hash map. So that has to have synchronizers on it, which of course it does. The next factory method is called Accumulator. It returns a by consumer that adds a new element to an existing result container. And of course, that result container is the one that was returned from supplier. And a very common thing to return if you've used array list and the array list constructor to make the supplier is the ListAdd method. And a non-concurrent collector needs no synchronization. So just keep that in mind because it's never called in multiple threads. Conversely, if you have a concurrent collector, then you need to have a method that will add new elements that is going to be thread safe. And of course, the add method on ConcurrentHashSet is indeed thread safe. So all that means is it needs to be synchronized. The combiner is a factory method that returns a binary operator that merges two result containers together. So here's a very simple example. If we were to use an array list, or any list for that matter, then here would be a common way to implement the combiner. We would take one list and another list, and we would add the another list at the end of the one list and return the one list. So basically, we're just appending it to the end of the list. And keep in mind, combiners are only used for non-concurrent collectors. For concurrent collectors, this would be a no-op. And if you set concurrent, then the combiner method will never be called. And then the fifth and final factory method here is called the finisher. This returns a function that converts the result container to the final result type. What the heck does that mean? Well, often the finisher is just the identity function. All that means is that what it returns is whatever the accumulator happens to be, and whatever the state of the accumulator is at that point, the mutable result container, that's what finisher will return. However, if you set identity finish, then finisher will never get called. Now, you might ask yourself, when would finisher ever get called? Why would you ever need to convert the accumulator, the mutable result container, into something else? And the best example, which we will not have time to go over at the moment, but we will get to later in the class when we talk about completable futures, is something that takes, for example, a list of elements of type T and turns it into a completable future to a list of elements of type T. So there's a really cool example we'll talk about later when we talk about future collectors or futures collectors. And this is super duper cool. And so in this case, the finisher really does something quite important and useful. But often it doesn't do anything at all, so we just set the identity finish flag and we're done. Okay, so that's the end of our kind of overview of non-concurrent and concurrent collectors, making it clear that they have different implementation details, but the general interface is almost identical. So you have, again, these characteristics that you can set that are kind of like flags or metadata. We've got supplier, accumulator, combiner, finisher, and so on. And those factory methods return data types that are obliged to have certain characteristics depending on whether or not a collector is concurrent or non-concurrent.